Kevin, it's great to have you here on the road to autonomy. I'm a big fan of what you and the team are building at Bedrock. We need more automation in the construction industry. Prior to co-founding Bedrock with your team led by Boris, is that you were building autonomous vehicles and autonomous trucks at Waymo. Why go from trucks and cars to autonomous construction equipment?
So we're looking for a few characteristics in a new venture. The first is business case that works really, really well. So at trucking, the way the industry works is there's people who build the trucks, there's people who drive the trucks, and there's companies that kind of like hold the assets. That's very similar to construction. So the business case works really well. And then, we spend a lot of time in self-driving, and one of the challenges with self-driving is safety. It's a huge, huge challenge. So we're looking for a space where autonomy can impact the work that's being done and accelerate the economy, but where safety and behavior aren't intimately tied. Not that we don't care about safety, we care about safety a ton, but here we can kind of decouple them a bit.
You're 100% right on accelerate economy. That's why I founded the Council for Economic Resilience to promote the positive benefits of automation and autonomy for the U.S. economy. And for the audience here, I want to highlight some data from the National Association of Home Builders as it relates to the economics of construction. The National Association of Home Builders estimates that there is a shortage of 500,000. That's a 500,000 individual shortage of labor in the construction industry, leading to construction projects being delayed on average by 2 months and driving higher carrying costs, which total $2.7 billion a year. And let's not forget, we're still in a high interest rate environment. Did you look at that data when you were looking at opportunities to go into construction? Wait a second, there's a growing labor shortage, carrying costs are high. If we automate that, we can have a really positive economic impact on the industry.
Yeah, absolutely. There's some crazy stats. The average age in construction is over 50 years old. And so people are retiring very, very quickly. The backfill rate is pretty low. And, the younger generation coming into this industry would rather be behind a desk, maybe behind a computer screen controlling machines than in the machines. So that's going to be a huge problem for the economy. We got to build data centers. We got to build roads. We got to build power and houses. And if we're going to do that, we need more labor.
We do. Then we have a lot of power constraints. I mean, that is a growing problem. If you look at your former home, Waymo, I was recently in Austin a few weeks ago and toured the facility. They're power constrained. They want to go to add more vehicles, but they can't get the power there. So that's an issue. And if you see what the president's doing with his executive orders on AI, we're going to need data centers. Do you see this autonomous equipment that you're building going to build data centers? And when I say build data centers, I mean leveling the ground, excavating it, getting it ready for the construction to begin?
Yeah, absolutely. Yeah, data centers are right on point. Anywhere where there's large foundation, where you need to dig ahead of time, roads the same way, houses the same way, big power centers the same way. You dig first and then you build. And we're providing autonomy to go do that.
What type of equipment are you looking to automate?
So the technology that we're building automates heavy machinery generally. We're starting with excavation. So excavators, wheel loaders, and bulldozers. And then, over time, we'll, probably build some foundation models and things like that can control lots and lots of machines.
So from a technical standpoint, how are you building the technology stack to enable these vehicles to work fully autonomously?
We built two things. One is a safety system. It looks like more traditional perception system that detects objects, detects the terrain around you, understands what's going on. And then we are using machine learning techniques to learn the behaviors that are used. And that's a combination of imitation learning and reinforcement learning.
So behaviors versus on-road, especially if you look at an 18-wheeler going down the freeway versus a construction equipment operating in a job site, behaviors are different. How are you getting that data set? Are you setting up test facilities? Is there available data? How are you getting that data set to build those behaviors?
So we partner with customers pretty deeply and put sensors on the machines, watch the construction occur, and then we can reproduce those behaviors.
Wow. So you're actually basically, if you want to use the term, you're putting them out there in a supervised manner before you make them autonomous?
We are not directly supervising autonomy in the same way that Waymo does. What we do is we just record we record the work that's being done. So we watch people doing the work, and then we can reproduce those behaviors directly while people are doing, this is just work that's being done.
So then you're increasing the overall efficiency of the construction site.
Yeah, that's right. So once we learn how to do those behaviors, we roll them into the autonomous system, and then we launch them.
Let's give you an example. So let's say in Ohio, for example, your equipment is building a data center, an AI data center, and then let's just say let's go to Nevada, and you're building a master plan community. The behaviors that you learned in Ohio, are those transferable to Nevada and vice versa?
Yeah, absolutely. Yeah.
Wow. And so what is that? Is that just the algorithms that you've written, or what is it that allows that to come to fruition?
We do a handful of things. The algorithms that we developed automatically learn the different styles of digging. So let's say you've got, you know, sticky clay in Arkansas and you've got powdery dirt in Phoenix. You want to be able to learn how to dig those different materials by collecting lots and lots of data on how people dig in those different environments. We get, you know, lifetimes worth of experience very, very quickly. And then we use machine learning to pull all of those behaviors in, learn every single one. And then when we're working in Phoenix or we're working in Arkansas, we just run those behaviors, and the machine understands the environment that it's in, and adapts to it.
Is that pressure data? Is that vibration data? Because if you sit in a tractor, and I've sat in them, you bounce, and then depending on if you're going into the sticky mud, you might be more heavier versus if you're going into a desert, it might be lighter. Are you putting sensors on that, or how are you gathering all the data? Because right now you have 4 construction partners. You're in California, Arizona, Texas, and Arkansas, completely different environments. So how are you gathering all of that data?
Yeah, so we put cameras, a LiDAR, and an IMU on the machine, and then we listen to signals coming back from pressures and things like that, and we watch how the machine moves. So let's say you're driving it and you hit a rock and the front end of the excavator picks up. We see that in the data, and we can learn from it.
Now, since you mentioned rock, so the environment that you're operating in is a lot different than trucks. You have dirt, you have dust, you have mud, you have rain, heavy torrential rain, and you have big rocks. How are you hardening the bedrock system to handle this? I'll call it this intense environment.
The old way that we used to do things was kind of hand building behaviors and detectors throughout the stack. So you would take all the LiDAR data, draw boxes around cars, try to detect the dust, actually try to filter that out. And that's a very, very hard problem. Self-driving car companies have worked on that for a long time. And part of the reason it took a long time is because they're hand designing every single one of these pieces. What we do today looks a lot more like building an LLM, where we have input data, we have output data, and we've got a big model in between. And that model is optimizing everything that you need to detect, and it will learn where the dust is and where it's not, and where that relates to the behavior that we're trying to output. And it's super, super efficient and super, super powerful. So we just learn it directly.
Without that LLM, let's go back. Let's hit the rewind button. I'll go old school and use the VCR rewind button, and let's go back 5 years. Would you have been able to build Bedrock as fast as you are today if you had the technology that we had 5 years ago? Or is it all the technological breakthroughs that have happened with LLMs today that are allowing you to do this?
Yeah, it's the last couple of years of development that really changed the game. I've looked at construction for many years. We did self-driving mine trucks with Caterpillar, sold the company to Cat to do autonomy in construction, and both of those times we looked at it, thought it was very, very hard. Imitation learning and these kinds of LLM techniques, language, things like that, all let us do a lot more than we could have, and all that's come about in the last 2 years.
So you have the old experience from selling a company to Cat. What have been those big changes since that transaction to where it is today outside of the LLM breakthroughs?
There's a ton of tailwinds that are helping us out here. Hardware costs are coming way down. Camera quality is way up. The dynamic range of a camera is huge today compared to where we started. Vehicles coming off the line now are typically drive-by-wire, which means you can kind of plug into a bus, turn on your software, and start controlling them. You contrast that to the automotive domain, where you have to build redundancy into the steering, build redundancy into the brakes. You don't need to do that for many of these machines. So that all lets us just basically turn on and go which is fantastic.
So you have the drive-by-wire, which is a huge breakthrough. So you have cat, and then another big equipment. You have deer. Is it similar to trucking where you have to go get the OEM partnership? You're at Waymo. You had a very public relationship with Daimler Truck, or are you able just to go to the deer dealer or the cat dealer and buy the equipment and deploy it? What does that look like from a relationship standpoint?
Right now, we buy the machines and we upfit them. If customers have existing machines, we can automate those directly. Um, in time, the OEMs are good friends. I worked at Caterpillar for a little while. We've got good friends over at Deere, uh, and all over the industry. So we'll see how it evolves. But right now, we just upfit.
Could it evolve into a powered by Bedrock partnership at some point in the future?
I think we have to wait and see.
Okay, well, there's a I'll use the term. There's a glimmer of hope there. How's that for you?
Absolutely. We'd love to, but we just don't know where that's going to go.
Bedrock comes out of stealth a few weeks ago with 4 construction partners. How did you initially get those partners? Was it pre-existing relationships? Were you pitching them? How did you get those partners to come on board?
People in the space we found are super hungry. Um, you talked about the labor issues and the demand for this work. Construction's growing, and so when we were starting the company, we called a bunch of friends who knew people in the construction space, and they introduced us to a bunch of wonderful partners. One of them, Sun, we've been working with from the very beginning. We had a call with them basically the first day we started the company, and we've been working with them ever since. They're super excited about the technology, and they see how it's going to transform things, and they want to be in there early. So it's awesome.
So take that one customer. So right now, 94% of construction firms reporting ongoing hiring difficulties. So are you coming and saying, wow, here we are with open arms? Has it been a very good positive relationships that you've been able to develop just because of the hiring practices?
It's not just hiring practices. Hiring is a challenge, but the construction industry itself is growing. There's a lot of demand for doing more. The technology that we're building lets you look at things like productivity, report how much work you've done, look back at all of the work that you've done. So if you want to insure a project, for instance, you built a foundation, and there's an issue with it down the road, you can go back and look at video of what you built. We also get to connect the construction site. So those benefits are really huge. Safety is also a huge deal. Construction's a pretty dangerous job, and there's lots of collisions with these big vehicles. So building a system that reduces injuries and fatalities is a big deal.
So let's use an excavator, for example. When you deploy, your customers, or not you, your customer deploys an excavator into their construction site. You mentioned video. Is that video recorded? So let's just say it starts day 1 and 4 weeks later it's done with the job. Is that whole 4 week of video recorded and archived?
Currently, we record everything.
Because I think of that from an insurance standpoint. If there's an incident, or sorry to go back to your Waymo thing, but we saw Waymo's won multiple court cases. People say, oh, the Waymo hit me. And then Waymo turns over the video and says, actually, no, this person jumped on the vehicle. It wasn't the Waymo vehicle.
Yeah, that's right.
Do you see a similar situation like that? Because if you look historically in the construction industry, there has been a lot of workers' comps, and there's no video, there's no data where you can say to the insurance company or your customer can turn over the video data. Here you are. Look, we're not at fault. Do you see that as potentially helping to lower the insurance cost that your construction customers are having to burden today?
I think that will happen, but of course, the other thing that we're going to do is try to prevent those injuries from ever occurring. So the video exists, and if there's a crack in a foundation, for instance, you can go back and look. So that's part of the insurance cost as well. For accidents, we'll be able to prevent most of them from occurring. Some of these things are harder to deal with, but many accidents on a construction site are things like somebody's very focused on the work that they're doing. They back up a big machine. They hit a pickup truck behind them. That's a pretty easy thing for our software to mitigate. And so all of those sort of accidents should go away.
So what type of perception range is your equipment going to have?
We're building a system to be able to do the work that's right in front of it. It's got cameras. The cameras can see very, very far. but the machines are mostly moving at low speeds. It's sort of like 3 miles an hour to 35 miles an hour. Our team has built systems that can see a kilometer, so we'll just build what we need to build. Right now, what we're focused on is really, really fine detail right in front of the machine. So if you're digging and you want to understand exactly how the Earth is moving in front of you, you're cutting through the soil. And we've got some really cool videos on our website of some of this stuff. You're cutting through the soil. You can actually see the sand dropping out of the bucket. You can see the clay curling up. And that all goes into digging really, really well, is how an operator would think about the problem. So that's really where we're focusing our energy. Really good detection, really good understanding of the terrain.
So that data outside of the autonomy stack, to me, so let's say pretend I'm a construction owner. That's very valuable data for me. I can get a really good understanding of the geography and then the terrain. How are your customers, the construction owners, operators, how are they using that? Because they're getting an immense set of data. And I ask you that because some construction companies, as with all due respect, can be overwhelmed by the amount of data that you're able to provide to them. How are you helping manage that data where they can, I'll use the term, they can make it actionable to help them increase efficiency in their businesses?
So we provide statistics. So things like, how quickly are you loading a dump truck? What does the terrain look like before and after? We detect situations that you might care about. So somebody gets too close to the vehicle. Somebody is standing in a hole that they shouldn't be standing in. We can detect things like that and give them events that they can go back and look at. So it's really summary information, and then all of the deeper information will be there as well.
Is that detection? Because if you have an individual standing there, an individual too close, is that a real time detection that goes to, let's say, an on-site safety manager that can get that notification in real time?
Yes, we can do it in real time. We can also inhibit behavior of the machine, so that they're safe in the moment, and then record it as well.
So there you go. So Bedrock's, for your technology, you're increasing and enhancing the safety on the job site. How does it work with the human interaction? So if you look at a construction site, you have your autonomous equipment and you have human driven equipment, and you also have individuals moving around in vehicles, in some cases walking. How does your system interact with that environment?
We're detecting everything that's happening around the vehicle in 360. So there's cameras, there's a lidar, and we're tracking everything. So people, trucks, other vehicles, the terrain itself. That's a 360-degree field of view. We've designed it to see with very high resolution out to maybe 15 to 20 meters. And then beyond that, out to about 100 meters, we get really, really good detections. So that's everywhere around the vehicle all the time. And when people are walking near the vehicle, it knows that, reacts, and makes a plan.
Wow. So today we're recording this as July 24, 2025. Bedrock has fully autonomous construction equipment out in the field, out in the wild today, operating on job sites.
We're currently testing the equipment on our own sites. We're launching soon with a customer. So we care a lot about safety. We're going to prototype these things on our own sites. We're data collecting with a bunch of customers currently, and then over the next 6 months, we're going to ramp up really fast.
So you're ramping up your job sites. There's a very famous individual that worked in this industry, Fred Flintstone. So you've called your company Bedrock. Was it influenced by the Flintstones? And is your test site, is it called the Slate Rock and Great Gravel Company? Is there a Flintstones tie here?
We are pretty influenced by the Flintstones. The name itself didn't come straight from that. We, Bedrock's the foundation, solid foundation that you can build on. So that was the original, the origin. But we do name our machines after Fred Flintstone, and Mr. Slate are both machines. So is Dino the dog. So we love the Flintstones.
And then don't forget Barney. Barney Rubble was a big part of the Flintstones.
Barney's out there too. Yes.
So you've got you have a lot of nomenclatures to name your autonomous equipment when you deploy it. You also have names to deploy your sites. When you send out a piece of autonomous equipment to the field, how long on average is it operating, and do you see that time that it's out in the field growing over time?
So initially, we're focused on narrow scopes. So we're mass excavation where you're moving a lot of dirt. Pretty soon, we should be able to do that close to human productivity and all day long. Over time, people do tons and tons of different things with these excavators. If you look at the distribution of things, it's kind of a power law from uh, you know lots and lots of volume of heavy moving. But if somebody's sitting in front of your house working on the pipes under the road, they're doing all sorts of kind of wild behaviors, little things that you need to learn over time. So initially, we'll focus on those narrow scopes and do a lot of that work. Uh, as we get better and better, we'll see those scopes grow, and the goal is to be able to do everything that a person does.
And so is the goal just to stay in construction, or will you eventually move out, which we've seen several of your competitors move into the mining sector as well?
Yeah, mining's not too different from construction. We see a lot of value in construction where we want to build houses, power data centers, and we want to accelerate that. So our focus right now is on that side, but there's really nothing stopping us from working on mining.
Do you ever see a scenario where if you're building a data center, perhaps you have to clear the land that your autonomous trucks can go in there, not just level the land, but clear the land, and then you can have a different truck that goes in and levels it and starts to do the whole stack, and then on the next part of that stack is, do you eventually go into the cement trucks and then to the pavers? Can we get a full? It's called a bedrock stack that Mr. Slate would be very proud of. Do we see that ever evolving?
So we're going after heavy machines generally, and so anywhere that these machines are doing lots and lots of work, and the value of that work is really accelerating the project will eventually work. That'll take time, of course, and some of these areas are much harder to automate than others. You've got messy concrete coming out of a concrete pipe. You got to figure out how to like move that implement around. Where excavation's a little bit easier, you can just get in there and dig. But the full stack is doable, and that's the dream: be able to build things as fast as possible.
Could you ever see that stack then expanding to on road? So Deere has a large road paver business. In those, they're going 2 miles, 3 miles an hour. And the gentleman that I know very well who runs the road builders, he says we need automation because it's such a dangerous job that people do silly things. They drive through there and they kill people. Unfortunately, they want to automate. Could you ever see your technology going to that since it is within the construction realm?
Absolutely, yeah. I think there is a fair amount of automation in pieces of the pavers. They follow a line. They're now GIS controlled. So I don't want to wave that aside. There's lots of good technology there. Doing things like protecting the machines from collision is something we certainly can do. There's also coordinated effort. You're driving on a highway. Maybe you've got a line of cones next to you. There are people walking around those machines. Automating those other pieces that support the paver and control the paver, I think, is really, really important, both for productivity and also for safety.
And then if you did that, do you have to modify what you've built from an autonomy standpoint, or can you simply take what you've learned and port it very similar to what Waymo did with the self-driving car, and then obviously to VIA? Can you start that as if you want to call it a base, and then you can either build or modify upon that base?
Yeah, that's right. So the algorithms that we're building are very general. So the process is like observe the work and then integrate that into the software. So anywhere that you could do that, we should be able to automate. Ultimately, we're building software both on the safety side and then foundation models that will control lots and lots of different types of machines.
What's the biggest challenge when you're automating this big equipment? Is it the controls? Is it the weight of the vehicle? Is it being able to protectly identify what the object is in front of you? Because I know that there has been historically issues correctly identifying construction sites and then grabbing something. What are some of the biggest challenges you have to overcome as you look to automate the construction industry?
I think the most interesting part of construction is the variability of the work. So if you look at self-driving cars, the description of what they're going to do is drive from A to B. It's pretty simple. Telling that machine to do that is straightforward. The nuance in how you drive is very challenging. For us, the the machine is a tool. You're doing something different every single day. We're on sites where they're changing the scope of work every couple of days, and so you need to be able to communicate with the machine. You need to be able to command it to do all these different tasks. You need to be able to react in real time to everything that's changing. And so the user interface is really interesting. And then the way that we build out the behaviors is important as well. You need to be able to control them. Maybe you need to be able to literally talk to the machine with natural language. Maybe you need to use CAD to tell it how far to dig. It needs to be able to see the things around it and understand and react to, maybe there's a tree in the middle of the field that you didn't know about. So you get all these surprises, and reacting to those surprises is the fun of the game.
Who controls that? Is it the construction partners, or do you just have a service layer that controls the vehicle?
There are going to be people sort of controlling these sites. Whether that's our customers or we provide a service, we haven't figured out yet. But people looking at user interface, and people in the field who see issues, and these are things that people are already doing. So people in the field, looking at issues and correcting plans, and then directly communicating with the vehicles.
But what you just indirectly said is job creation. You said the stat earlier that the average age is 55. Well, if you get a 19, 20, 21-year-old that wants to go into construction, they can run the app and run the autonomous machine. That's a job creation that really helps the overall construction industry. I'm curious. Let's say you sign a deal with Acme Construction Company, and they say, "Hey, Kevin, we need you to go to the site in Arkansas and deliver the trucks." You deliver the autonomous truck. What is the first thing that you do when you drop off the autonomous construction equipment at a site for a customer?
We want to slot that machine into the process that they already have. So they'll go out and do a survey. They make a plan for the site. They've got drawings of what they're going to do. So we ingest those drawings. So somebody will load those drawings in. There might be some work to translate it into a format that the machine understands. And then once the job's set up, you push go. The machine starts doing its work. There will be a cluster of these machines working together. And so somebody on that site very likely is going to be sitting in sitting behind a computer screen, watching these machines do their work, watching their productivity. And I think that's an awesome job. I could sort of think about it like playing StarCraft, and being able to control all of the different pieces of the game.
It's a real life video game. Kids have grown up in video games, and we go back to the 80s. You're gonna rot your brain out if you play video games all day. Well, some individuals became very successful and founded very, very good companies that have gone on to change the world, and they've gone on to change the movie industry. If you look at what the Unreal Engine's done, wow, that's a pretty big, incredible breakthrough there. As you ramp up and scale, and you understand the Acme construction site, so you have one human to one machine. How do you see that scaling over time? Could you have a human overseeing, say, 30 machines on a site, 10 machines? How do you see that human to machine ratio changing as it scales on a site?
Yeah, I think it's going to vary with the sites, but the sort of intelligence of problem solving that the people do today is still going to exist. Somebody's going to do that behind a desk, and so it's going to vary a little bit with the complexity of the site. I think that ratio is going to be pretty large. You're going to be controlling the whole site.
When this happens, this happens all the time in construction. The foreman calls, change of plans. This is what we're doing now. How do you ingest the change of plans into the machine? Is that going to be the operator on site that will put in the new plan?
Yeah, that's right. Somebody is going to draw on a map and say, actually, I need a trench here that's 3 feet deep. They go out, they spray paint on the ground, and they say, follow this line, dig out this area. We want to be able to do all of those things, so fit seamlessly into the process.
So you're able to do that because of the perception system that you're developing at Bedrock?
Yeah, that's right.
Wow. So basically you're giving you're giving the construction equipment the ability to see, and then the person is giving it the ability to think. When do you give the construction equipment the ability to think and make decisions?
I mean, the construction equipment is, if you sort of like look at the hierarchy of a construction project, there's different layers of decision making. There's things for where does all my aggregate come from to build a road, all the way down to I'm navigating around in an excavator and I'm digging the material around me. So we'll do reasoning sort of for the on the ground work. Over time, I think you get to a point where magic happens. You can actually sort of like plan out the operation of a construction site. You get to know exactly how long it takes to do a particular job, a particular piece of that job. You can optimize. If you're an owner and you're running one of these projects, you optimize the amount of time that it takes because you've got a duration that you want to fit the project into. You can ask, do I need another machine on site? Would that speed things up? If I want to take a little bit more time, how do I do that? Can I lower costs? So that'll be a planner that runs on top of the rest of the software. So you can sort of look at this and see how far it's going to go in time.
Because when you get to that point, you give that construction owner or operator the ability to properly budget time, and that's the number one thing. We got to get this done on time. You say, okay, well, let's just hypothetically say, okay, we have 3 Bedrock autonomous construction equipment running. If we add a 4th one, we can get in on time, and that's going to do X dollars to our budget. You're giving all the planning tools needed, and then that's going to create success overall.
That's right. And you also know in a really detailed way the work that machine can do and the amount of time that it takes to do that work in a way that you just don't have today. We know scoop by scoop how much dirt is going into a truck. Today, that's tracked on a piece of paper generally. The truck driver says, I did this many loads, and the excavator operator says, I loaded this many trucks. And if they disagree, there's a fight or a lawsuit. We get that for free automatically, just coming directly off the machine.
So you're getting all this data off the machine, and at some point, this is a hypothetical, but based on your technology, you could automate dump trucks. Then let's go back to the stack analogy. Then do I see it read a press release, say 2 years from now, Bedrock OS for construction sites to manage your entire construction site because all the data you're getting? Is that where this evolves?
Absolutely. Yeah.
Okay, so you're building it. That's where it goes. Well, today, let's go back to today. Are the drawings, is that the fuel that enables your system to go? And so when the robot ingests the drawings, so the way it goes, and then in the future, that becomes the operating system?
The operating system is more than just the drawings. There will be displays where you can see all of the vehicles, see their progress, see what's happening on the site. If you need to radio to a machine, you can do that, or communicate with language. Stats will come back, and you can see the progress of both the individual machines and the site overall. Optimize it, and so you can imagine that several different kinds of user interfaces and pieces that we'll have to build out.
So basically, on a construction site or back at the construction headquarters, there could basically be a map. They can see all the pieces of equipment, where it's moving, how it's moving, and then get the whole data feed essentially. So they you're going to call it a command center.
That's right. Command center, and not just that site. You should be able to see every site that has our equipment on it.
And that's going to live with you, or will that live with your customers?
The customers will have access to that.
So you're basically, the common denominator that I picked out to this entire conversation is that you're giving your customers the ability to scale, and scale very big.
Yeah, that's right.
So as we go into a site and you're allowing your customers to scale and truly grow their operations with autonomy because of the growing labor shortage, do you have to pre-map the site? How does that work from a mapping perspective, or you're able to do it mapless?
Right now, we do it mapless. We'll do drone flyovers. This is a common practice in construction, is to do drone flyers ahead of time and after, to do before and after drawings. Because of the data that we're getting back in real time, we just build a map online immediately when we start. We scan the LiDAR around the site, and we get the 3D terrain. We line that up to drawings, and then we go. So no pre-mapping required.
I hope your drones are autonomous.
I don't think drones are allowed to be autonomous right now, but someday. Yep.
Someday we'll get there. How big of an opportunity do you feel that the construction TAM is for Bedrock?
It's massive. It's massive. There are $120 billion of excavation contracts, just excavation, in the United States. There's millions of vehicles and billions and billions of hours of work that goes into these projects. We've seen multi-billion-dollar projects that went by the wayside because they couldn't get the people together to do the work, and so there's a big TAM today, and then that TAM is going to grow.
As the TAM grows, what are you and the team at Bedrock hoping to achieve?
I think the TAM growing is an indication that we're building more. And I live in the Bay. We need to build more housing. I'd love to see that happen. Uh, we've talked a bunch about data centers. We need power for those data centers. We're going to see those come together faster and faster. The whole thesis that we have in the United States is to elevate the work that we do over time, and AI brings that promise. We want to start to do work in the real world so that we just elevate all of the things that we're doing and go faster and faster. That's the goal.
The goal is you're going to build something special. That's my opinion. Autonomy is the key to scaling construction because of the growing labor shortage. Without autonomy, the construction industry is unfortunately not going to be able to grow as it does. And as Kevin rightly said, need more housing in San Francisco. Not just San Francisco, there's various markets around the United States where we need more housing. The population is growing. Our tummies are full. We need housing. And autonomous construction equipment will allow us to do that. The future is bright. The future is autonomous. The future is Bedrock Robotics. Kevin, thank you so much for coming on the road to autonomy today.
Grayson, thanks for having me. Appreciate it.